Okay, I guess try and get started here. Can everyone hear me okay? It's okay. Okay. I'm Kevin Rice. I'm the Digital Services Librarian at Rutgers Newark School of Law. And today we're going to have kind of a panel presentation on the topic of document delivery formats for the web and their issues related to legal digital collections. There's three of us that are going to talk today, myself and John Jorgensen. He's a reference librarian at the Rutgers Camden School of Law. Both him and myself manage digital library projects. And then the third speaker is Luke Vincent. He's from the Lizard Tech Corporation, and his company develops software for a particular document format, the DjVu document format, which he's going to discuss in detail later in the presentation. Just to get started, what I define a delivery format for a digital collection is that it's the type of file that a user receives when they're accessing a document in that collection. These are, the format is not just important for the user's viewing of the document. It's also important for information retrieval tasks like full text indexing, or how you're going to build your search interface for the collection. There's no one format that's right for every type of collection. Your material and the format you're getting that material in is going to dictate what you're going to do. But for my portion of the time, I just wanted to kind of raise some general issues that I think are important to think about when you're picking a format, and then go into some detail about the different actual formats that you have to choose from. Okay. The first issue I think is very important to think about when you're picking a format is the idea of an open versus a closed format. Who's in control of the format that you're going to build your collection in? Is it a standards body, or is it a single company or organization? And if you're going to invest a lot of time and money in building a collection, can you really reliably count on something that one entity controls to be supported over time? I'm sure every IT person here has had to deal with some long disappeared document format to try and get the information out of it. So I think, especially for us in the academic community, it's very important to work with open formats, formats that are going to be interoperable and have support over time. Open formats that they integrate well with open source or low-cost processing and information retrieval tools, and working with open formats will help you today as a web content provider who needs to deliver information to a wide variety of devices and platforms. The second issue. Second issue that's important to think about is the usability and accessibility of a particular format. This is going to impact the user's experience with your collection. You have to think, what software are the users going to need to look at my collection? One very important question is, can a web browser natively display it, since that is the most common way that people access digital collections today. And if it doesn't natively display in the browser, is the plugin to look at the document, is it free? Is it a format that users are likely to have experience with, have on their machine? I mean, we work in an increasingly closed computing environment, especially in offices, given all the trouble with viruses. So you're going to want to have something that people are familiar with. Maybe your users won't have the opportunity to install the viewing software because they have to wait for their IT department to do it, to look at your collection. Another thing you want to think about is, do public search engines index the format you're using? This can help the visibility of your collection. And then also, since there's still such a large number of people that use modems to access the net, how palatable is the format and software that you're using to view the documents to the modem user? Is it going to work in a low bandwidth setting? And the last main point that I I think these are just my own observations, and what I've discovered working with the staff in my library is these are subject-specific concerns for building legal collections on the web. Well, the number one thing is legal projects, the ones that I've worked on, and almost everything I've seen on the web, they manage text, not images. So you're going to want to pick a format that lets you get at the text and do a lot of interesting things with the text. And then another concern is some types of legal material may be harder to maintain the collection, especially if you're doing a project with something like codified material that's being updated frequently. And then thirdly, almost all legal materials are exclusively black and white. At least the print, they're in black and white. So it's very important that you're going to pick a format that, let's face it, almost all the material that we look at is black and white text on a computer screen. So you're going to want to pick something that's going to be useful for that. Another thing is the preservation of the page structure of documents is important for citation purposes in a lot of areas. But maintaining the original appearance of, say, a digitized document is not that important. But having access to the text is. I mean, archival or rare materials might be an exception to this, but by and large, people want the text. They don't really care if it looks exactly the same as it did on the original print document. These are some of the formats that I've seen collections, legal collections put up on the web in. There's pure image formats like TIFF, JPEG files, and then what I would call open encoded format. These are XML, HTML, plain ASCII files, or now Unicode text files. These are your plain text formats, kind of like the core of the web. And then there's a lot of what I would call hybrid formats, PDF, Adobe PDF documents, and the DjVu format, which are formats that contain both images of the text and can contain a layer of the text. And then lastly, there's I've seen some projects that have actually put proprietary formats like Microsoft Word or WordPerfect files up on the web. Just kind of wanted to mention some issues about these different files. You have your pure image files like TIFF and JPEG. These are raster image files, pixel-based. These collections are almost exclusively composed of scanned documents. And while something like TIFF may be a good choice if you want to have an archival version of your scan, it's not necessarily a good choice for the web. The advantages of these formats is you're not going to have to worry about plugins for the browser. Web browsers display them natively. They're both what I would term an open format. There's published standards and manuals for them, and it's well supported on all computing platforms. Some negative issues with these files is they're often quite large, making viewing them on slow connections problematic. The text of the document is only available if you run an OCR process on them. You're going to have to use optical character recognition to get at the text. They have a weak support for multi-page documents. It's pretty much one file, one page. So you're going to have to do a lot of extra work to manage these if you want to display them in as a document whole on the web. A particular issue with JPEGs is they have trouble displaying text when they're compressed for a level appropriate for the web. And then one thing that's working on the digital library project has been proved very useful to me is the ability to embed some metadata in the document format. And these formats, while they contain metadata about the physical file itself, the physical image, page size, color, they don't allow you to really put metadata in that describe the contents of the file. And probably when you're working with image formats, the most important thing to think about is what OCR you're going to use. Because working with this text, we want to build something that's functional and searchable for people, enabling them to find information. You're going to want to use an OCR software that's going to be be quite powerful and give you a good understanding of the words on the page. One thing to point out, if you're a 5% rate of error in your optical characterization has been shown not to impact the traditional information retrieval measures, the relevance measures, but a 20% error rate significantly degraded the performance of traditional IR techniques. But the good news is, today the OCR software has progressed quite a bit recently, and you can get high-quality OCR for a relatively low cost. One package that I just started working with was the ASCII Fine Reader, which you can get for $300 for the professional edition, and it does some complex text, even like a table and page layout recognition, which was pretty spotty on some older OCR packages. The next formats are what I would call the open encoded formats. These are your plain text formats. These are typically easy to integrate into digital libraries because most digital library software really puts an emphasis on indexing these types of formats and creating interfaces that utilize these formats. Typically, you would create these in three ways. These would be born digital documents that have been actually created in these formats or exported from an authoring tool. They also could be manually keyed in if you're doing an archival project where you have people actually keying in, transcribing the documents into these formats. Or they could be created from what I would call corrected OCR. You would do an OCR of a scan and then take that file and have someone or a program try and correct it and mark the page structure of the document and then index it. It's pretty easy to build IR applications with these. Build a full text search interface to a collection. The benefit of these is they're all international standards or W3C recommendations. They're accessible with all the current web technology. It's easy to embed metadata in them that can be created with any text editor. Improvements in OCR that I just mentioned kind of make encoding scan collections more feasible because if you get a good OCR, it's not that much work to write a program that's going to put that at least in a loosely structured encoded document, which is what I do on our particular project, which I'll mention briefly at the end. Some negatives, they can be time-consuming and expensive for staff to create if you're doing a manual encoding. If you're doing, or if you're going to do manual correction of the OCR errors. To get the full benefit of these, you really need to have some expertise on staff of people who can process text. So it may not. They give you a lot of freedom to innovate, but you have to have some skill and experience to get the full benefit. And they don't necessarily preserve the look of a print document if that's what you're going for. And then lastly, there's hybrid formats, which are kind of could be a combination of both of the two formats I just mentioned. Like there's Adobe PDF and DjVu, which are both proprietary technologies, but they have a substantial amount of support in the open source community. So that it's not like you're going to run into the problems of the vendor disappearing and not being able to support the format. They both contain a layer of a document's text and an image of each page in the document. They both can. They don't necessarily by default do this. They both utilize cross-platform, freely available web browser plugins. They both try to preserve the look of a print document. They're also easy to create born digital versions of these documents using printer drivers. I'm sure everyone here has used the print to PDF function. The DjVu format also has that as well. Some specifics about PDF. Of course, everybody has used it. It has very strong market acceptance in the legal community. You're not going to run into the problem of having users having to install the plugin. One other thing to point out, it's also getting increasingly standardized. There's a movement to define a PDF archive standard being headed by the AIM Association, Association for Information and Image Management. So this could give some added permanence to PDF. Adobe is pretty open about the format. They make the reference manual and software development kit available to developers. There also is a standard methodology for embedding metadata in the documents. Adobe's now using what they call the XMP, Extensible Metadata Platform. It's a pretty interesting approach to embedding metadata in documents that seeks to be compatible with the semantic web technologies that are emerging from the WC3. It's worth taking a look and at the web page at least. See that approach. Some negatives with the PDF. I think probably everyone has experienced this. The plug-in performance is quite poor for long documents. In fact, it seems to be getting worse with each version. At least that's been my experience. It seems to get slower and slower for loading documents. And PDF composed of scanned images seem to wind up to be very large in file size and cumbersome. The DjVu format was designed from its inception to be a scan-to-web technology. Some advantages of it are it's got the best compression of any image format on the web. It's going to give you the smallest file size. Users can load lengthy documents very quickly with the plugin. The plugin is pretty friendly to developers. It's pretty easy to manipulate. There's a manual of how to control its display, highlighting of different regions of text using CGI-style arguments, which we probably see a demonstration of that later. Some negatives are it doesn't have great market acceptance in this community, so your users are probably going to have to go out and get this plugin if they're going to want to look at your collection. DjVu, it doesn't have a standard way to embed metadata in the document format the way PDF or you can do with HTML or XML documents. Just lastly, I'll briefly mention proprietary formats. They're not a good choice at all for a web collection. They're completely closed. They're like Microsoft Word is certainly not going to go away, but you still have the problem that if users don't have the software, they have to pay for it to look at it. And then lastly, I'll just mention our project. Later on, I'd like to maybe show some demonstrations of how it works. But this is our current workflow. Our project is called the New Jersey Digital Legal Library. Our mission was to digitize New Jersey legal materials that currently aren't available online. We decided to make our documents available to users in DjVu and PDF for access issues, because we ran into the problem of a number of users from the New Jersey court system contacted us and say, oh, we really want to look at the materials you've put up, but unfortunately, our IT department has put us on the bottom of the list for installing the plugin on our workstations. Then we decided to also make PDF versions of the collection. Our workflow is, we scan the documents to TIFF format, and then use the TIFF format as the source for generating the PDF and the DjVu process, the DjVu documents. We extract the encoder that we use for DjVu has an OCR engine in it, and which puts a layer of the OCR text in the document. I extract this text from the DjVu to actually XHTML files using some XSL style sheets I wrote, and the DjVu Libre, which is an open source DjVu library that has a export to XML feature that I use to create an XHTML file that marks the page structure with div tags. And then I use Swishy, the open source indexing engine, to index the documents, and along with embedding a Dublin Core metadata record for each document. But now I'm going to turn it over to John, and he's going to talk about his project at the Camden Library.
Okay. That's a smooth transition. make this look pretty. There we go. Hi, my name is John Jorgensen. I am a reference librarian at Rutgers School of Law in Camden, the other law school at Rutgers University. And I've also been managing several digital library projects over the years. And what I would like to do today is, I think Kevin has talked about a great deal of the technical aspects of the digital image formats. I'd like to go through a brief description of the kind of things we've been doing it as an application of what Kevin's been talking about, and maybe just talk briefly about why we should do things like that. Our current imaging projects. For a while now, we have been doing New Jersey administrative law decisions. Ever since Barclay Publishers was acquired by the West Publishing Company, there has been no print publishers for New Jersey administrative law decisions. At that time, we actually mutually contacted each other. Our invitation letters crossed in the mail. And we started publishing the New Jersey administrative law decisions on the web. It was kind of interesting from an imaging point of view because about half of those decisions are actually generated by the commissioners of the various departments and not by the New Jersey Office of Administrative Law, and none of the commissioners wanted to cooperate with this project at all. But fortunately, they were in the habit of sending a copy of every one of their decisions to the New Jersey OAL, and they started sending them not to us. And so we started getting into the business of digital imaging of documents. There are some advantages to dealing with the ones we're getting from the OAL. They are short and simplex, small pun, because they're only on one side of a page. So we can use fairly inexpensive scanning equipment. Just anything with a sheet feeder was fine for us. In fact, we use our fax machine right now to do the scanning for these. And it works great. It works great. They're usually less than 15 pages, unbound sheets. We just stick them in the machine, which has a little connection with the computer. It's got a scan function, and they get done quickly. And we've been doing it for quite a while that way. Metadata issues. I mean, we've been talking about metadata issues. These documents that we get are all related to an initial decision, which is usually more lengthy, which is produced by the New Jersey Office of Administrative Law. We get that in originally digital format. We lift metadata out of that using some Perl scripts at initial processing, but the metadata for those initial decisions is very much the same information we want to keep for these decisions that we need to scan. So we have pre-collected metadata from related documents, and we can use them back and forth. Only PDFs are needed, so when we scan these, we actually scan them using another very similar product to the FineReader. We use OmniPage Pro, which I haven't actually used FineReader ever, but it seems like a very similar project, and it's about the same price, I believe. OmniPage might be a little more expensive. But it works quite well. So we scan straight into OmniPage. That immediately OCRs it to a PDF image on text format. This is the kind of thing that Kevin was talking about as a hybrid format. PDF is actually very flexible. You can make fairly small files with scanned images, fairly small, this is a relative term here, by just scanning to a PDF pure image format. Not searchable, but it'll be viewable with a PDF plugin, like Acrobat Reader. That's okay if all you want to do is look at a document. We wanted this to be searched in full text, so we used the much more bulky and hard to use image on text format, but you get the scanned image, and you also, that's what the people see when they look at the PDF document. But underneath that, embedded in that, is the text, which makes it searchable in full text. Another project which we're just starting to get into now, the parameters of which haven't been decided yet, is our government document project. We're having a crisis of space at Rutgers Camden, which is something that, if you're not facing now, is something that all librarians have small nightmares about, or big nightmares. We're really running out of space. One of the things we're running right now as an experiment to deal with that is getting rid of our government documents print collection by converting it. We're starting out with our hearings, congressional hearings and print material. It was kind of interesting. We contacted our regional GovDocs librarian and said, okay, we want to withdraw all of the material older than 5 years from our collection, and we're going to destroy the print and scan it. But we want to withdraw it now. They said, hold on. We got in contact, they put us in contact with somebody else from the government printing office. The GPO is actually starting to gear up a project to convert the back file of all their print materials. And there's a possibility, it hasn't been settled yet, but there's a fair possibility that this project that we're going to be doing is going to be a part of the government documents, or the GPO's scanning projects. So we're still kind of negotiating about imaging standards and how we're going to be archiving the material, you know, et cetera, et cetera. That's going to go on for a while. Yes?
They are even reconsidering the 5-year rule.
Yes, they are reconsidering the 5-year rule. For now, they just want us to work with the stuff that's older than 5 years, because it's still not clear whether this is going to be just our project for stuff that we're officially withdrawing, or whether it's going to be a GovDocs project, in which case I think they are going to let us do everything, even stuff that's younger than 5 years. But for the technical aspects of this, it's all bound material, usually greater than 200 pages per item, which makes its own problems all on its own. The GPO is telling us for this text material, they want 600 dots per inch uncompressed TIFFs. Bitonal is acceptable for text. This creates, my personal opinion is 300 dots per inch is probably more than enough for this. That's certainly good enough for OCR, and it's good enough for viewing, but the GPO is asking for 600 dots per inch. They want MARC records preserved as metadata for this, and it's still, we're talking about how we want that encoded. Right now what I'm doing is I'm developing a system which is going to take MARC records from the Library of Congress for all of this. Since it's hearings and prints, there are independent MARC records for each item, and loading that into a separate database and using that as identifying metadata to help locate items. We're going to do secure archiving of the TIFFs. We're going to do that by burning things onto CDs. And right now, we're going to be using Mitsui Golds, which are supposed to have good archival qualities, unlike the vast majority of CDR material that you can buy. We can talk about, the reasons for that later. So for some reason, I went back a page. Hold on. Okay, the working format for what we're going to be displaying is, again, PDF image on text, just because we want the material to be searchable in full text, as well as displaying images. Now, why are we doing that? And we talked before about scanned images being very bulky, taking up a lot of space. We're working on a system to do it in batches of no more than 25 pages per PDF file, which will make it usable or practically usable for most people to look at this stuff on the web. And just to briefly show you what I'm talking about, we're going to be doing it all through CGI, and it's going to look something like this. If you can see the bottom here, it says 1 of 100, which is the point which I realize this is going to be totally unworkable unless we break it down into 25-page batches. But this is the middle of a hearing on electromagnetic radiation from electric transmission lines. You can see everything's being accessed through a CGI if you look at the URL on the top there, where it says insert title from metadata here. When I work out the database, the title of and some identifying information is going to appear on the margin there. And every section of the document, we're looking at the shorter second section of it here, so you can see part 1 and then part 2 is identified there. That little arrow would move up and down to tell you which file of the full document you're looking at. So you'll be able to look at the whole hearing file, or whole hearing in 25-page chunks. You'll be able to search for material using, again, we also use the Swishy search engine. It's a wonderful freeware search engine. This is the kind of search results you get. I also just wanted to show you this because this is interesting to show you the kind of results you get. You could see the PDF image we looked at. That is an image. It looks like an image. When we index this material, again, we use some CGI scripts. I use PDF to text, which is a freeware converter. And what it does is it takes the PDF file, converts it on the fly into text, and then with the CGI script, it's pumping it through the Swishy indexer, which I may have said that way too fast, but basically what's happening is the Swishy search engine is getting the raw text, the dirty OCR'd raw text that we OCR without any proofreading. And since it is above 95% accurate, it's pretty good for information retrieval. So, but if you look at this, you can see, just looking at the search results, this is taking a quick sample of what we searched for, and you can see the search terms I had, transmission line, are highlighted. But you can see a couple of errors in here. But it's not bad. So there's the word power. I don't know if that little dash there should be there. But again, acceptable search results. I found what I was looking for. So that's the kind of things that you can do and that we are doing with this. How am I doing the time, Kim?
It's close to 5 after.
Okay, I'll be moving along here. So, okay, difficulties and compromises. Again, time and money. It's a lot of time, and there's time and money that's involved in doing this. Since we don't have a large budget for doing this, the procedures that we've been developing are specifically designed mostly and primarily to save time and money. First is I was talking about dirty OCR. OCR, unproofread and uncorrected, is still about, I think, about 97% accurate from the current generation of OCR programs like OmniPage Pro version 14, ABBY Fine Reader. The dirty OCR is good enough for searches. It's not good enough for display, just as pure text, but if you do something like image on text or DjVu, it's good. Again, just as I said, less than 100% accuracy means that images must be displayed. The file size get very big, so they must be split up, and creative program is needed. If we had $1 million to throw at this, actually a couple $100,000 maybe, we'd be able to do corrected OCR, convert it all into a pure text format, maybe even encode it, and then we wouldn't have the problem of these huge files. We'd have ASCII XML encoded files that would transmit over the internet in no time flat. But that's not going to happen without a large influx of money that's not forthcoming. So we do the creative programming. Metadata, an important issue. The first thing we do, when at all possible, is teach the machine to get it. That's what we can do with the New Jersey appellate decisions, because we have those electronic initial decisions that we can run some Perl scripts, some regular expression searching, and we can lift out the names of the party, the name of the judge, the date of decision. the first paragraph of text, which is usually a pretty good summary of what it's talking about, enough good and identifying information to be able to move forward. We're borrowing and reusing for our congressional hearings that we're working on now. We're going to be using the Library of Congress MARC records. And the LOC control numbers are going to be used as the key field. So like we're going to have 5 files of 25 pages apiece in PDFs. They're all going to be named with the LOC control number from the MARC record with a cutter to identify each part of the file. So it'll be the LOC control number -1, -2, -3, etc. And that'll make it easy for the computer to tell which order you want to display the parts, simple enough, but then still know what document you're talking about. Make it mutable, use a database. We're going to be uploading all of this into a MySQL database, just like we do with the administrative law decisions, etc. We're doing that for several reasons. A big reason, number one, it's fast and very usable and very easy to write CGI scripts to make it accessible on the web. Number two is to make it mutable. If we want to change formats, if we have a search engine or somebody else has a search engine who wants to index our stuff that uses a certain data structure, it's very easy to write a CGI script which will extract this data, format it any way you want. We're just going to be storing the raw identifying data in the MSQL or MySQL database. You can format that as a Dublin core tag. You can format it as some sort of XML encoding with or without Dublin core, whatever you like. So, collected data, format of the collected data can be whatever you want. Okay, why do we do this? I don't want to get off on a rant here, but I probably will. Lexis does this better than we do. They have the money, they put all the value added into it. Why should we bother? Another thing I've heard when I've spoke on topics like this before is some very irritated people actually telling me that this is not the business of libraries to get into producing material like this and putting it on the web. It takes too much time and resources away from real library work. I would like to ask the question, what is a library? When I was at CALI last year, for all of you who were at CALI last year, there was a phrase that was repeated several times, even by the keynote speaker. Ownership versus access is an important and key issue that we all must think about. And then he went on to say nothing about that. I'm not blaming the guy. It's a very difficult issue. Everybody talked about ownership versus access and then said nothing about it. Well, we need to do something about it. Academic libraries as repositories, we must own the information. If you're working in a law firm and all you need to do is make sure the lawyers get what they want when they want it, subscribing to Lexis and Westlaw is fine. It's a great solution. Is that a great solution for an academic library that wants to be a repository of information for the long term? No, no, no. We need to own our information. And if we are locked into Lexis and Westlaw, just like the man was saying yesterday morning, buying into the old church is not working. We're not a repository anymore if we must rely on it. We have to find ways to own the information, even if it's electronic. Thomson, Elsevier, and Kluwer will never give ownership to anyone for any price ever, because then they won't make any money anymore. They won't do it. So we must move around them. So for many types of materials, I recognize that developing ownership is going to be problematic. You just can't take a recent treatise and scan it and pretend you're not violating copyright laws, and the hammer will come down on you. But what about the things that we can do? What about your government documents collection? What about case law? What about all primary source legal materials the stuff that takes up the most space in the library, the stuff that's most valuable to most of the people who use your library most of the time. All of this stuff is in the public domain. So I would like to introduce the idea, I believe Bob Baring may have said this once in the past, of guerrilla librarianship. Okay, collection development by other means. Okay, if you have material that's taking up too much space, scan it, publish it, make it public, save your own space. Okay, give it away. Give it to other libraries to also have it. You know, it is the ultimate disaster avoidance plan. If you scan a whole collection, give it away to 100 other libraries. If you have a huge computer disaster and it all goes away at your institution, there are still 99 intact copies. Why not? We're not in this to make money. We're in this to share information. Grab material from the source. There are a lot of ways to do this. There's a lovely little Unix utility called wget. You type wget and then a URL and it will download an entire website. I tried this with the Department of Justice and really crashed my computer once. But it was a lot of fun. wget can also be wrapped as a nice little utility within a shell script. As a librarian, what am I going to do now? I'm going to decide and do collection development decision on what's important to collect from the U.S. Department of Justice. Things that are new, things that are important, things that change when administrations change, that are going to disappear without a trace. I can use wget with a little script with a list of what's important, and it will periodically download all the new stuff. You can use it to check and see what has changed. If the file sizes have changed, if the file size changed, they've changed something. Download the new copy, store it, index it, make it available to the world, whether they like it or not. It can be done. It's perfectly legal. Why not? And then you have it. Indexing remote resources. Even if you're not going to download it and store it, why not index somebody else's stuff to make it more easily available? It's still theirs. You're not taking it. Just make it available. My conclusion is that imaging projects can be made affordable. With newer OCR, there is a new generation of mid-range scanning devices that are just wonderful. We just bought a Panasonic duplex scanner. It was $1,000, not a whole lot of money. It's significant, but not a whole lot. It is beautiful for what we want. The real expensive ones do colors and all kinds of, image depth, but it does great bitonal scanning, very fast, with a huge hopper to take things in on. Affordable. It's not like it used to be. Creative use of free and low-cost utilities make it all doable. And my last thing is I'm quoting a guy who helped me get into library school years and years ago. What really is the difference between a publisher and a library when you're talking about an electronic world and electronic data? The only difference is that publishers wish to make money and libraries wish to provide the information. The only difference is a difference of attitude. I think we have a better attitude, and I think we also have a duty to collect stuff and start making stuff available. And so for a new way to also make stuff available, I'd like to introduce, Luke from Lizard Tech.
Okay, so My name is Luc Vincent. I'm the VP of Document Imaging at Lasotech, and I want to give you a very brief overview of DjVu and what it can do for you. Let's see. So to some extent, my punchline has been stolen already by my distinguished colleague Kevin here, but I'll show you a few examples to try to make his points more clear. So since we're running out of time, I'm going to skip over some slides and go straight to some more detailed information. So I wanted to talk about the drawbacks of using sort of standard accepted image formats for documents. And I'll talk here about color documents, but the same is true to a large extent with TIFF Group 4 for byte-only documents. So say you have color documents and you want to use JPEG to store them. There are a bunch of issues with this. First of all, the page size remains very large. You need at least 300 dpi if you want to be able to get good text quality. At that resolution, a letter size page will be at the very least 400K or half a megabyte if you're lucky, more like 1 megabyte plus, which is okay for storage perhaps, but for email or web delivery, it's very large. Also at that level of compression in JPEG, you will get ringing artifacts around the text, which you probably have all seen, so it looks kind of ugly. You also keep the text and the image together in one big blob, and therefore you can't really run OC or you can't really search on the text. You just have one image of this text. Viewing is, can require large amounts of RAM also because you have to decompress the full page, so it's not really possible on portable devices like this, for example. Page navigation is impossible. Also, JPEG is not really a document format; it's a image format, and there's no multi-page representation in JPEG. So a bunch of issues, and JPEG 2000 is an improvement, but it is nowhere near good enough yet, I think. So that's some of the reasons why DjVu was introduced, and DjVu rely on this, at least for color documents. And I'll go into the black and white case specifically later. But for color documents, DjVu relies on this representation called MRC, which stands for Mixed Raster Contents. Essentially, the idea that you can represent a color document by segmenting it, if you want, into a foreground and a background. The background being here, whatever is texture of the paper, background color, tint, photos, all that would go in the background layer. And the rest, which is typically only the text or some graphics, will go in the foreground. The reason for doing this is that you can then represent those types of objects separately. You can compress the background using, in the case of DjVu, using something known as IW44, which is weighted compression. The idea being that you don't really need full resolution, but you need full color. So for those images and this paper texture and this tint, you can just reduce resolution to, say, 100 dpi without losing anything, pretty much, without losing any visual quality. But you need the full color. So weighted approach is totally appropriate. However, for the text, for the foreground, typically it's black. Okay, typically it's black or very few colors. So you can get by with using very low color, low number of colors, like you palettize the colors, but you use original resolution, very high resolution, 300 dpi or more. Okay, and here we use a semi-ability compression called JB2. So now, which brings me to my point, what exactly is DjVu? I would say it's three things really. It's from the bottom up, it's really it's a technology platform called that is embedded in a number of products to create very, very highly compressed representations from scanned documents. So it's a set of algorithms, to recreate this, to enable this high compression delivery. And finally, it's really an open file format, which has a ton of interesting features from the point of view of making scanned documents available on the web or efficiently distribution, for efficient distribution. So let me go through these features and I'll illustrate them with some examples. Okay. So first of all, one amazing element is the compression. So with DjVu, it's not unusual to get 1,000 to 1 compression for color documents. So a scanned color page at, say, 400 dpi would be typically around 45 megabytes. You can expect this page to be around 50K in DjVu. And it's done without losing much quality. It's really what we call a visually lossless type compression. You keep the full color if it's color, full resolution, etc., etc. A side effect of the segmentation we do, which is to put the text on the background, is that you get very reliable OCR, even from color documents. Even from documents that have pretty degraded text, like old documents, you can just pull the text from the background, from the texture of the paper, and OCR it well, using a good OCR engine. So you're going to get better value out of your OCR through DjVu. It's also, even though it has great, features that are sort of web features and text search features, etc., it's really an image format. Okay, so what you have is a snapshot of a page. Therefore, to render it, you don't need any font, anything. It's totally portable. It is far more portable than a PDF, to name one, because PDF requires system fonts, and you may always get, Asian PDFs you won't be able to see if you don't have the Asian font packs installed. So, with DjVu, there's no problem, no fonts. I'll show you it's also very optimized for web viewing. And finally, it's an open standard. It's not, unlike what Kevin was saying, it's not really a proprietary format. It's a format that is fully published on the web. Specs are published, and it's also open source. So no matter what happened to Lasertech, and to any company supporting DjVu, the open source will stay and will enable you to always work and use your DjVu documents. So let me show some examples, really, because that's pretty much all I have time for. So here's a page that I scanned from a magazine page, InfoWorld, 400 dpi, 45 megabytes. Okay. In Tiff, raw Tiff. So you can't do anything with this. Even if you have the disk space to store it, disk space is cheap. You can email this around. You can serve this to your customer on the web. I've tried a variety of products to get PDF compression out of this. It's still pretty big in PDF, even with the most advanced compressions in PDF. I went down to 273K and lost some quality here. I can show you what it looks like. It's still fairly slow to load, as usual with a PDF document. In fact, it's going to take us a while. Pretty all seen this. I think some people calculate that hundreds of millions of dollars are lost in productivity in the US because of the slowness of this plugin. It's true. So anyway, it's here. See how it's also fairly slow to browse. The quality was all right, but it didn't actually separate the text from the background here. So see, it's like the text is wavelet encoded here. So it's not a good format. So in comparison, the DjVu is 56K here. So from 45 megabyte, 56K, it's 800 to 1 compression. You click on it, boom. The difference is quite dramatic. It was less than a second to load this. On the web, it will be pretty much the same thing. So what I want to show you here is that let me just zoom out. So I can show you just the background. See, we found the paper texture, the image, all this to be the background, and it's got that pretty high quality. Okay, and now the text is here. Okay, that's my text layer. The text is actually also searchable completely because I can just copy, paste. Here's the text. I say copy text. I can say run. Oops. Notepad, and here's my text. Okay, so my document collections are always going to be indexable and searchable in many ways. So if I look at the page information here, I can see what the size of different chunks really are in this document. We've got the foreground, which is a text, which is 20K, and the background here with the different chunks of IW44 encoding was about 20K as well, and we have the actual text information, which is 5.8K. So without text, the document would be even pretty much under 50K. So quite dramatic. You might wonder, what does really color, how does color help you? And you mostly deal with black and white documents. I would argue that even with black and white documents, you often will benefit with color. For example, if you get old documents, some collections here. Here's one example. A cookbook. Well, it was scanned in color because you actually can preserve the appearance of paper texture much better this way. So even in DjVu here, you have the appearance of an old book. Here it's not indexed, there's no text. But you can really see what I mean. In fact, if you scan in color, you will often get better quality results. You will get the same file size pretty much as you scan in black and white, not much difference. And you will get, you will pull the text out better. You will not rely on the scanner to do the binarization for you. You rely on the advanced DjVu algorithms instead, and therefore get better quality on your text. So something to consider. Let me move on here to my presentation. So I want to say just a few words on how we do the text compression. So it's based on what's known as token-based compression or symbol-based compression. Essentially, you find repeating shapes in a page. You don't even need to know what these shapes are. They could be anything. It could be music partition. It could be Arabic. It could be Chinese. Don't care. We just find that these shapes repeat in the page, and there's fancy algorithm to decide when two shapes are the same. And then you just encode, like here, this S will encode only once, and then encode the position of this S on the page and the color at different locations. So that gives you dramatic compression because you also do this over multiple pages. So you can expect that compared to TIFF group 4, you get a factor of at least 3 and very often up to 10 times better than group 4. So page size would be typically under 10K in DjVu. Let me show you an example here, which in fact is an example I just created from an example I got from Kevin. It's a New Jersey administrative records, volume 13. Right. So it came as single pages. TIFF is tons of them, 43 megabytes of TIFF files, kind of unruly, impossible to do much with. In DjVu, we're down to 4.3 meg, so a factor of 10 compression compared to already compressed group 4. I can go here now and browse to any page instantly. Page 510, boom, I'm there, and I can just flip through pages. You see the speed of flipping through pages. It's just completely, dramatically easier and faster than PDF. And I should say it's a free plugin. I'll get to that in a second. So that's for this example. I'm just going fast because time is running out. I want to show you also how the OCR is better because of DjVu. Let me show you an example that's I think telling. Here's a page of a Shopper Image magazine or catalog, and notice this text here is actually, we extracted it. It's right there. You can search for stereo sound soother even in images. It's going to be present. So there's no way you could extract this kind of information without without being able to first segment the page as we do. What else? So one of the key features which Kevin already discussed is the fact that DjVu has this hidden text editor, which I already showed earlier. So essentially, instead of taking a scanned image and trying to convert it into pure text or into Microsoft Word or into an electronic document format, we just keep a snapshot of this page. We compress this snapshot extremely well, okay, and then we use text as a hidden layer. So text is present, is extracted through OCR typically, okay, and you can extract this text with different ways, like we have free tools like DjVu to text, DjVu to XML. We have integration with Microsoft Windows with an AI filter. We have integration with different search engines already. So if you have a DjVu document collection, you can search it very easily. Let me show you an example of a kind of fun thing that I did. I was telling Kevin I work from a home office, so I used to have filing cabinets full of tons and tons of technical papers. I got sick of all that paper lying around, so I just scanned everything into DjVu, of course, and indexed it with a free JavaScript-based engine called JSS, which is free available also, and already DjVu integrated. And now I can just search my collection. I've got, I don't know, tens of thousands of pages in there. I can look for, in front of mine here, boom, here we go. And this is like it's served over my home DSL line here. So you're talking, very, very little bandwidth and instant access to a very large collection using totally free software. Let me keep going here. Yes, just one thing also. DjVu was redesigned for scanned documents, especially scanned document, but it's great for electronic documents. That whole presentation here is in DjVu, as you may have noticed. So I can just zoom in, zoom out. I can get my text. So it was printed to DjVu from PowerPoint. And when you even consider electronic PDFs, like here, you can just get it. It varies widely, okay, but you can expect a factor of 2 to 100 reduction depending on how the PDF was created, okay. So for example, here this G43 product overview here is 4.6 million in PDF and loads very slowly. Okay. The same one, oops, I lost it. The same one converted to DjVu is 148K. Boom, it loads really fast. Notice that when I go from page to page, the text appears first, and then as you're reading the text, the images appear. So it means that on very slow bandwidth connection, you can always access the information instantly, what matters to the text, and then the images refine themselves in front of you. Just a few words on the browsing. So there's free plugins for all platforms, pretty much all platforms that matter: the Mac, Windows, Unix, Linux, even Windows CE. We are also going to introduce very soon a plugin-free viewing option through Java, and I can even show you a demo of this, a preview of this technology. The plugin is really teeny. Even it's a 900K download compared to 16 megs for the PDF plugin. It's auto installable. So you click on install, and it just does it for you. You have nothing to download. And it's really designed, I think, to minimize any kind of viewing delay. So from the ground up, I think DjVu is half compression and half web delivery. And this half is all these different technologies that combine to make the viewing experience really enjoyable. So it does progressive page rendering. It lets you access page in any sequence instantly through this indirect DjVu method. As you're reading a page, it's going to prefetch the next page and the previous page just in case you want to move to it. And it's going to do real-time zooming and panning as I showed earlier. Finally, it also lets you customize the appearance of DjVu documents, that when you display it to your users. And also supports, hyperlinks. It supports, ActiveX and embedded DjVu in pages. So it's really what we call web-friendly. It blurs the line between scanned documents and the web. Here's an example of how you can customize the view. Here's a 747 manual, actually just marketing manual. And notice here on the URL, I specified DjVu ops, actually it's here. DjVu ops, and then say thumbnails, yes, zoom equal width, and I have a whole bunch of parameters I can give here. So that, hey, for these documents, whenever somebody clicks on these documents, I want them to show with thumbnails on, like here, and a zoom level that's the width of the page, etc., etc. So it makes it really easy for you to design your website, your web document collection in a way that makes sense for you. So, finally, again, it's an open standard. You can get the whole source code, for DjVu lib here, and SourceForge. Therefore, I think it's a great format for archival. You should probably archive, if you have an archived DjVu document collection, save it along with the source code, so that 100 years down the road, you can still, compile the source code and use your documents. So that's it. I'll probably just stop right here, because I'm out of time. Yes?
I have a few questions. Since it's a layered
yes.
file, how would you print it out? Do you flatten it like you do in Adobe Photoshop, or you screen?
So it depends on how clever the printing is. The printing from our plugin right now is print and makes a big image that makes it print. But on the previous plugin we have, it actually creates a layered PostScript. So it's a it's a full resolution text. It's a each element of the page that is over resolution. And then so it's very fast.
I have another question. People want to go somewhere.
Sure, I'll stay here for a while. So,
Oh, okay. Well, some of them want to stay.
sure, we can.
Let's assume that your current technology, the scanners that you have around, you have scanned PDF,
Right.
you get it emailed to your computer.
Right.
Now, what? If you download the DjVu, would you just import the PDF?
So if you get a PDF file,
You have already a PDF on your computer, on your hard drive.
Right.
When it was scanned PDF, though, the text
the
is
scanned
part of
PDF.
the image. It's not there. If you convert it to DjVu, would it make the text searchable?
Yes, you great. So you have to re-OCR it right now.
Okay.
But that's just because technically the way that hidden text is stored in PDF is not a documented feature in PDF. So it's actually hard to get to. So right now we could not in fact get that text easily. So we would just re-OCR it.
Okay. Is there any work on the scanners that would scan to DjVu rather than yes.
So we so we have our own products. We have a product with Document Express, and we're working on integration with all the major scanner vendors. In fact, in a couple of weeks, maybe less than 2 weeks, we'll be announcing a partnership with Kodak. So Kodak scanner shipped with something called Kodak Capture or Capture Lite, and we've now done we scan directly. Yes.
A couple of questions. One is, how do you view DjVu in relation to Adobe Acrobat? Like, would you say it's a replacement or alternative?
No, I think it's a complement. It's a complement. I mean, I think we're not going to replace PDF overnight. We just think that it is far better for scanned content, scanned documents. So there's no reason not to have both the PDF and the DjVu plugin installed. The DjVu plugin is very, very lightweight and easy to install.
And so PDF security level is still one of their fortes, right?
Security in PDF, yeah.
Yeah, whereas DjVu doesn't really have that.
We'll have this down the road, but it's not really our focus right now. But we'll be at some point.
Is your presentation up on the web?
I'll make it available on the web. In DjVu.